Improved Piping Products Incorporated, an engineering design company and manufacturer of flanging systems, distributing nationally and servicing clients worldwide, has developed a selection procedure for flanges used on high-density polyethylene pipe, HDPE. This user-friendly system provides the engineering community with a high level of confidence that each selection made from it can offer the desired safety factor selected by the engineer. Unfortunately, reliable flange standards for the thermoplastic piping industry do not yet exist. So what do you write in the specifications for backing rings? Improved Piping Products is your answer. At Improved Piping Products, it is our mission to help you write specifications so that the piping system you design is safe, functional, and cost-effective. The American Water Works flange standard ratings for Class 150 flanges, AWWA C207 Table 2 Class D, formerly known as 1D, are based upon how flanges behave when welded onto steel pipe. When bolted together, the opposing forces neutralize each other via the full-faced gasket, and there is a marked absence of deflection. This creates a stable joint and assures a safety factor of 2. On HDPE applications, the free-floating rings are able to uplift at the pipe wall. They cantilever and rotate at the edge of the flange adapter, creating a rotational force in an axial direction around the edge of the adapter. This creates stress levels at approximately twice the magnitude of welded 2D flange, which exceeds the yield point of the flange material. Unknowingly, many design engineers have specified the flanges in AWWA C207 on HDPE piping applications, thinking the stated pressure ratings were applicable. This misapplication is the basis for the information that follows. IPP has used finite element analysis to evaluate each and every flange size shown on AWWA C207 Table 2, Class D, and Table 4, Class E, up to 63 inches, and has concluded that C207 is misused in specifying flanges for HDPE piping applications at the stated pressure ratings, if a traditional safety factor of 2 is desired, as it is for steel pipe applications. IPP recommends that the pressure ratings in AWWA C207 not be used for HDPE pipe. IPP employs sophisticated engineering computer software in order to design its products. Finite element analysis is used to determine primary levels of hoop, axial, radial, shear, and von Mises stresses. This design tool is recognized for accurate stress analysis and allows for results that are verifiable and reproducible. Finite element analysis represents the ultimate in structural analysis for the most sophisticated systems to ensure long life and safe operation. We will show the results of our research by comparing the von Mises stress diagrams of 2D flanges welded to steel pipe and as loose backing rings on HDPE. This graph plots nominal pipe size on the x-axis and operating pressure on the y-axis. The blue line represents the AWWA C207 Table 2 Class D standard, which rates sizes 2 inches through 12 inches at 175 psi and larger than 12 inches at 150 psi. Now, let's look at the red line, which depicts what the ratings of the flanges truly are when used as free-floating backing rings on HDPE pipe. These ratings also assume a safety factor of 2. As you can see, the ratings called out in C207 are, in the majority of sizes, not applicable on HDPE pipe. Let's examine the 24-inch 2D flange in more detail. On the screen, you can see a von Mises stress diagram of the flange when at a test pressure of 200 psi. The flange is overstressed at 35,680 psi, seen at the lower left-hand corner of the flange. Accelerated stress corrosion and joint failure could result. The stress must be lowered to 16,000 psi to provide for a safety factor of 2. C207-1994 specifies a minimum yield strength of 32,000 psi for plate steel material. How can we do this? We can make the flange thicker, thus increasing the section modulus. Now we see how much thicker the flange must be in order to provide the proper safety level. The piece, which is increased in both weight and thickness, is much more difficult to install and costs substantially more than the 2D flange. Typically, an engineer strives to design a system that fits the client's needs, is functional, safe, and cost-effective. As you can see, C207 flanges will not accommodate all these criteria. The misapplication of C207 and the pressure of market forces has caused thinner and thinner flanges to be selected, leading to systems that are held together by strain-hardened materials operating at stress levels between yield and tensile breakpoints. The reduced section modulus of these flanges increases the potential for accelerated stress corrosion and ultimate joint failure. There is a way to reduce the weight and cost of flanges while maintaining safety. Improved Piping Products has patented a unique design trade named Deltaflex. It is the modern high-performance backing ring for HDPE piping systems because the total mass of the flange, compared to a 2D flange, is reduced by 30% or more and redistributed in a patented configuration that outperforms the 2D flange. Note the unique cross-sectional design and the manner in which it seats to the HDPE flange adapter and mates with its counterpart. The unit is lightweight, easy to manipulate and install, and incorporates the following important features: the I-beam principle for weight reduction, redistribution of mass to the critical load-bearing areas for maximum strength and stress reduction in the joint. The Belleville washer principle is utilized for storing energy in the bolts, eliminating the need for retorquing. Better corrosion resistance due to the Deltaflex being made of ductile iron as opposed to the 2D, which is made of carbon steel. If we examine the von Mises stress diagram for the Deltaflex in the 24-inch size, we can see that the stress is approximately the 17,900 psi necessary to achieve a safety factor of 2 in ductile iron. In order to make the backing ring selection process less confusing, IPP has designed its products in conjunction with the most commonly used SDR pipes in the industry. Our standard lines include SDR7 and SDR11, with many more to choose from, and all are designed with a safety factor of 2. Since we are an engineering and design company, we also have the ability to custom make backing rings for any application. What if IPP doesn't have a backing ring with the exact SDR rating as that of the pipe being specified? A simple calculation provides the answer. For the purposes of illustration, let's say you have specified 12-inch SDR9 pipe, but IPP can only offer SDR11 or SDR7 in this size. You can choose to use the SDR11 backing ring. However, the safety factor will be less than 2. The calculation for determining the safety factor is simple. Take the pressure rating of the backing ring, in this case 160 psi, and multiply it by its safety factor of 2, which equals 320. Divide that by the operating pressure, or SDR, of the specified pipe, 200 psi, yields a safety factor of 1.6. Using SDR7 backing rings would yield an ample safety factor of 2.67. If you were to use the AWWA C207 Class D flange with an actual pressure rating of 60 psi, you would yield a safety factor of 0.6. Now you can make a decision about which safety factor is more appropriate for your application. Choosing the proper safety factor will eliminate joint failure, leakage, and the need for bolt retorquing. IPP Deltaflex backing rings have gained acceptance into a wide segment of the overall piping market and are being used in the following applications: water and wastewater, gas, mining, landfills, shipbuilding, NASCO approved for U.S. Navy Coast Guard fast deployment fleet, factory mutual, and many more. One look at the list of customers and projects IPP has supplied will show that Deltaflex is recognized worldwide as the preferred backing ring for use on HDPE pipe. Deltaflex are made of ductile iron and are available in a variety of coatings, such as epoxy, hot-dip galvanized, and our new polypropylene encapsulated. They are also available in 316 and 304 stainless steel for highly corrosive applications. Our warehouses are conveniently located in San Leandro, California, Houston, Texas, and St. Louis, Missouri. Or you can get Deltaflex from any one of our hundreds of distributors nationwide. Thank you for taking the time to learn about Deltaflex and its benefits when used in conjunction with HDPE piping systems. Millions of our backing rings are in use worldwide. Including Deltaflex in your master specification as the preferred backing ring will ensure safety and peace of mind while helping to keep you within budget.